Section 2.3, real zeros of polynomial functions. So again, still more review of Algebra 2 or math analysis, and we're just going to jump straight into the problems here. So we're going to do a quick review of dividing by long division. So what we're going to do is we're going to take out the divisor, which is the number on the bottom, and put that out in front. And what we're dividing into on the inside. And make sure that you have this in descending order. So highest power first, moving down to the lowest power. Okay. With long division, it's basically the number, the first part here that's in charge of everything. So every time we divide, the 4x is doing the work for us. So I'm going to do 4x times what gives me the first term, which is 4x cubed. Well, that's going to be an x squared. I put it immediately above the first thing that I multiply it into. So now this gets multiplied. So I'm going to take the x squared and multiply it times everything in front. X squared times 4x is 4x cubed. And then 5 times x squared is 5x squared. Every time you do that multiplication, that needs to be subtracted from the previous line. So watch your signs on this. The 4's are going to cancel. The x squareds are stacked up. They're like terms. Let's go ahead and combine those. I have a negative 7 minus 5, so this is going to give me a negative 12. Bring down the x squared, and I normally just bring down one term at a time. Now I do it again. 4x times what gives me negative 12x squared? Well, it's going to be negative 3x. Multiply those together. I'm going to get a negative 12x squared and then a minus 15x. Once you're done with that, you subtract it. The 12's cancel, or negative 12's cancel, which is exactly what we expected it to do. And then negative 11 minus negative 15, that's going to give me a positive 4x. And then just bring down the next term, which is going to be a plus 5. Well, 4x on the outside goes into 4x down here once. And then multiply it times the top. So 4x plus 5, that gets subtracted. This works out nicely. We have no remainder. So I would say that dividing, going back up, this is going to be equal to whatever we got on top, which was x squared minus 3x plus 1. No remainder. Okay, question 2. Again, I'm just following the exact same questions that you have in your notes, and I will have them written out beforehand because you already have them written out in front of you as well. So I want to determine if x minus 3 is a factor of that polynomial f of x. To determine if it's a factor or not, you can do it a couple different ways. You can do long division, and if it goes in evenly with no remainder, then it's a factor. If you want to, because we have a binomial, so x minus 3 is 2 terms, and it's got a leading coefficient of 1, it's a 1x, you can actually do synthetic division. So I'm a big fan of synthetic division, so I think that's what I'm going to do. So if x minus 3 is a factor, then that means that it's equal to 0. In order to do synthetic division, you need the 0 that goes with it. So I need to put 3 into my synthetic division, see if it works. And a couple of you may have seen this a couple of different ways. Basically, the format is the same. I normally take the value that I'm trying to determine if it is a 0 or factor or not, and I put it in a little box up on the side. Then I go back to the original problem, and I take all the coefficients off in order, making sure that you fill in any gaps. So I have a 1x to the 4th. I have no x cubed. You need to put a 0 there. I have a negative 10x squared. I have a negative 2x, and then a positive 4 constant. Then I put down my plus line, and your first number always gets dropped down, so I just put a placeholder of 0 there. Add. Once the number comes below the line, it gets multiplied times the number in the box. So 3 times 1, and that goes on our next plus line. Add that straight down. Underneath the line gets multiplied times the number in the box. Add, multiplied times the number in the box. Add, multiplied times the number in the box, and add. The remainder is always going to be the last value in the corner, so right in the table. So there's your remainder. Because there is a remainder, this is not a factor. So I would say not a factor. And that's because you have a remainder. All right, question 3. Again, same one you have written down in your notes already. We just want to show that those two are factors and find the remaining zeros. All right, so I'm going to do the same thing, but I'm going to set up a synthetic division chart this time. I'm not going to do a whole bunch of little tables. And again, this is something that you should have seen last year or 2 years ago. And basically, it allows you to do multiple synthetic divisions without having to rewrite the table every single time. So I'm going to go ahead and just set it up for my x minus 2. So I'll go back up here. X minus 2 means that you have x is equal to 2 and x equals negative 3 for the plus 3. So those are the values that I'm going to put into my synthetic division chart. All right. So again, more of a chart this time. Take my coefficients off in order. I had a 2x to the fourth, a 7x cubed, a negative 4x squared, a negative 27x, and then a negative 18 constant, making sure that anything that's missing, like an x cubed or an x to the fifth or whatever, has a 0 in its place. You need to have a placeholder for it. Okay, so let's make a chart out of this. I think the first one I'm going to check is the 2. So that 2 for me goes off to the side. Now, what gets absorbed here is that plus line. So you end up having to do the plus line in your head. If you have a hard time with this, then you can just do a whole bunch of different little synthetic division tables instead of a chart. So the 2 gets dropped down because I'm plussing 0. Now I'm going to do the number out that I'm trying to determine if it's a factor or not. 2 times 2, the number that was dropped, which was 4, that's going to get added to the 7. So again, I'm doing the plus line in my head. Now 2 times 11, which is 22. 22 plus negative 4 is going to give me 18. Now times 2. 2 times 18 is 36. 36 plus negative 27 is going to be positive 9. 2 times 9 is 18. 18 plus the negative 18 that was there, that's 0. This is good. That one works. Now, I'm going to use this again, but I'm going to use the resulting answers, the 2, 11, 18, and 9, and the next one I need to check is the negative 3. Now, I'm not looking all the way up at the top of the table now. I'm looking up at the previous entry because it worked. That resulting polynomial is what I'm going to divide into now. So I'm going to drop the first 2, multiply it times the 3. Negative 3 times 2 is negative 6. Negative 6 plus the 11 that I have there is 5. Now, negative 3 times 5, that's going to give me negative 15. Negative 15 plus the 18 that is there is going to give me 3. Negative 3 times 3, negative 9. Negative 9 plus the 9 that is there, that is 0. Okay, so now what I've done is not only have I done my synthetic division, but I broke it down into a polynomial that has dropped its degree twice now. So the beginning was an x to the fourth, so my 2 up here, that was an x to the fourth. This 2 is an x cubed. This 2 is an x squared. I can handle those. I don't need a synthetic division table or chart or anything for that. And I'm trying to find the factors or the zeros, so set them equal to 0. All right, now from here, you can either try to do P's and Q's, which I don't think is necessary. You can use the quadratic formula, or you can factor. I think I'm going to factor. Okay, so let's factor this thing then. So I've got a 2x and an x. Again, if you're a box person, you can go ahead and do that. I am not, so I'm just going to factor it this way. All right, so I got 2 other factors. Do quick multiplication. Does this work? Yep, it sure does. Then, let's see, look back at my question. It says, find the remaining factors. Okay, I found the remaining factors. It's 2x plus 3 and x plus 1. I want to write the polynomial in prime factorization form. All right, so This started out as an f of x. So I already proved the first factor worked, which was x minus 2. I proved that the second factor worked, which was x plus 3. And then I was able to get the 2x plus 3 and the x plus 1. Let's do a quick check on this. If you were to multiply this out, you would get an x to the fourth, and you would get a 2x to the fourth, which is important. So I want to make sure that we get the leading coefficient correct. Yeah, you can go ahead and multiply out the whole thing, but I'm fairly confident that this is good. Okay, so we want to write a polynomial function of least degree with the following zeros. We definitely want integral coefficients, all of the same things that we've done before. So I would say this is another example of stuff that we've just done in previous sections. So I know that the factor that goes with the 4 is going to be x minus 4. I know that the factor that goes with this one is going to be x minus 3 plus root 29. And then I also know that the conjugate has to come with. So this is going to give me x minus 3 minus root 29. So just like the problems that we have done previously. Now we're just going to multiply this out. So I'm going to have f of x, or p of x, or k of x, whatever you want to call it, x minus 4. Just bring my stuff down, show that I actually want to multiply. And then I'm going to multiply the conjugate ones together first. So that's going to give me an x squared minus a 6x plus 9 minus 29. Combine those terms. And then I'm just going to bring down the x minus 4. Then from here I'm going to do the same thing. Just multiply it out, combine like terms, see what you got. I'm going to go ahead and fill this in, so now would be a good time for you to pause, do it yourself, and then check against mine. Okay, so when I multiply it out and then I went ahead and combined like termed, I get the polynomial on the bottom, which is of least degree, so I didn't add in any other factors that didn't necessarily belong there in the first place, and it does have integral coefficients. So I am pretty satisfied. Let's move to the next question. All right, so now I want to divide. Now, I'm going to show you a couple different ways that you can do this one. This one's a little tricky because of that you have something that isn't an integer. You've got a half in there. So my recommendation to you is to make sure that, well, I would probably rewrite the bottom so that it's a different factor, but something that's equivalent to it as well. So off to the side, I'm going to take this x plus a half. And I want to rewrite this as something that it's equivalent to and would give me the exact same thing. So let's say that this is a 0. Then I know that I could get x is equal to negative half. So if I'm going to do synthetic division, I'm going to put negative half in the box, which is one of the ways I'm going to do it. So for synthetic division, this is what I am going to put up in the box. And I'm going to go ahead and just set that up to the right-hand side right now. I'm not going to do it yet, though. But if I wanted to do get rid of any other fractions, I can take this x plus a half and I can kill the denominator of 2. This is going to give me 2x plus 1 equals 0, which if I were to get the 0 that goes with it, I'd still minus the 1 and divide by 2. I still get x equals negative half, but the dividing might be a little bit easier. So I think I am going to take this one and I am going to use this with long division. So you can do this a couple different ways. You can do the long division or you can do the synthetic. But you got to be really careful if you're going to do the synthetic. So let's go ahead and do the division longwise, see what our answer is supposed to be, and then see how that compares to the one for synthetic. All right, so I have a 4x cubed, 16x squared, 23x, and a 15. Okay, so I'm just going to go ahead and do my division like I normally would. So this is going to give me a 2x squared. Multiply that out in front, and then subtract. Do your subtraction, drop down the next term, divide, multiply it times what's out in front, subtract, drop down, divide, multiply, and subtract. Okay, so the answer is going to be this 2x squared plus 7x minus 15. And if I were to multiply this out, I get the 2x times the 2x squared gives me the 4x cubed. This works. This is good. Let's take a look at what happens with the synthetic division, though. You better get the same answer with the synthetic division. If you don't, you did something wrong. So let's take off the coefficients in order. So the first one is a 4x cubed, a 16x squared, a negative 23x, and a negative 15. All right. Add my 0, do my synthetic division. So drop my 4 down, multiply it. Negative half times 4 is negative 2. That goes on the next line. Add. Negative half times 14 is negative 7. Add. That's going to give me a positive 15 when I multiply in a 0. Okay, this works. But now let's take a look at what happens with the resulting polynomial. I'm going to get a 4x. It was a cubed, so this is a squared, plus a 14x minus 30. Okay, here's the issue. This is not even close to the same as the answer from the long division. The green and the yellow boxes are supposed to match, but they don't. The issue is that with the synthetic division, whenever you're performing synthetic division with a fraction, you're actually doubling if the denominator is 2. So because my denominator of my fraction up here is 2, you are doubling the result. If it was 3, you would have been tripling the result. If it was 5, you would have times by 5 the result. So in order to get the correct result, we're going to have to take this and divide it by the fraction denominator that you had up in the box. If we do that, we're going to get 2x squared plus 7x minus 15. So by dividing by 2, we now match. So honestly, it doesn't really matter if you choose to do long division or synthetic division. The long division, it will catch you. You don't have to worry about the division part at the end. The synthetic division, a little bit easier, but if you don't remember to divide by that denominator, you're in big trouble. You're not going to have the correct resulting polynomial. Okay, number 6. find all real zeros of the function. All right, so the first thing I'm going to do is I'm going to label out my p's and q's. So remember that the p comes from the end and the q comes from the beginning, and they're all the factors of those. So I'm going to pause and fill in all of my p's and q's. Right now would be a good time for you to pause and see if we match. Okay, so here are all my possibilities for my p's and q's. And if I had this on the no calculator part of the test, then I would set up a synthetic division table and see what happens. If this was on the calculator part of the test, I would type this into my y1 and then I'd go to my table. And I think that's what I'm going to do. Now, I still need to be able to prove algebraically that something is a zero or a factor, so I'm going to do that. But I'm actually going to grab my calculator. So I'm going to go to my y equals button. I'm going to clear out anything that's already there, and I'm going to type this into my y1. After I've done that, I am going to go to my table. And what I'm looking for is I'm looking for y values of 0. And when I did that, the first y value of 0 I found was when x was -2. So what I did here is I look for y equals 0. And I found that. I found it when x equaled -2. So now I'm just going to prove that -2 actually works. So I'm going to see if I can find more than that. So I need a couple of these. So let's do a synthetic division table. All right, so my coefficients in order, I have a 6x cubed, excuse me, x to the fourth, a 25x cubed, a 26x squared, a -4x, and then a -8 constant. All right, make sure that I wrote those down correctly. And then again, my calculator showed me -2. So I'm just going to prove that -2 works. So, and this is something that you have to do. It's not necessarily something you can grab out of your calculator other than the multiplication and the addition part. So I'm going to drop down the 6 and I'm going to multiply. So -2 times 6 is going to give me -12. -12 added is going to give me 13. -2 times 13 is going to give me -26. Added is going to give me 0. -2 times 0 is going to give me 0. Added is going to give me -4. And then -2 times -4 is going to give me +8. Added is going to give me 0. Okay, this works. This is good. Now, but this is still something that is a cubic, and I don't think it's factorable just by looking at it, so I'm going to keep looking through my calculator. As I keep looking through my calculator, just at the table features, I'm not seeing anything else come up. So I'm going to go to my table set. And on my table set, I'm going to change the increments. So for my table set, I am going to go ahead, leave my table start wherever it is, because I'm probably somewhere in the ballpark of the -2 that I just found, and I'm going to change my delta table. Now, looking at the options that I have in my P's and Q's, I could have a half, a third, 2/3, 4/3, 8/3, a sixth. I'm going to shoot for the half. Hopefully that one will work. So I'm going to change my delta table to be 0.5, so the halves. Then I go back to my table, scroll through my table again and see if I can find anything other than the -2 that's going to give me a 0. Aha, I see the half. Positive half works. This is nice. So I put the half in here, and then I perform synthetic division with the values above. So drop the 6 down. Half of 6 is 3. Added gives me 16. Half of 16 is 8. Added gives me 8. Half of 8 is 4. Added gives me 0. This is good. Okay, so I take a look at my resulting polynomial now. So that's going to give me 6x squared plus 16x plus 8. I'm looking for zeros or factors. Now, remember what I said on the previous slide. I just did the synthetic division with a fraction, which means this is all divisible by 2, and it needs to be dealt with. So I'm going to go ahead and divide everything by 2 to get it back down into the polynomial that I expect it to be. And actually, when it's equal to 0, dividing by 2 on both sides is really what you're doing, and 0 divided by 2 is just 0, so you're not really doing anything to it other than shrinking the numbers down to the values that they're supposed to be at. Now, from here, let's factor, because I'm really looking for the rest of the 0, so I have to keep working at this. So, I'm going to 3x and a 2, an x and a 2. That gives me 6 and 2, which is 8. Okay, this is good. If I solve this, I get negative 2/3, and I get negative 2. Interesting. So my negative 2 showed up in the table, and it shows up in my in my factoring. That means that there was multiplicity. So if I took a look at my graph, you notice I never even looked at my graph because I don't think I need it. Not for this question. There would have been a bounce in the graph at negative 2. So had I hit in the graph button, I could have just done negative 2 twice in the table instead of changing my table set. But figure gives me a little bit more practice with my table set. So now I'm supposed to find all real zeros. All right, so my zeros are always going to be x equals values. The first one that worked in the table was negative 2, and that actually showed up twice. So we need to say with multiplicity of 2. I also know that I got, I think it was positive half to work in my table. That only showed up as one answer though, so I'm going to only write it once. And then the other one that showed up from the factoring is negative 2/3. Okay, and I have all of the real zeros of my quartic. All right, application problem. It's the exact same question that you have in your notes, so let's take a look at this. I've already got it written out the same way that you already have. So we have our rectangular package sent by a delivery service have maximum combined length and girth. We explained what girth is of 120 inches. Show that the volume of the package is given by the function. All right, so the function itself. So v of x. This is still going to be a rectangular-based prism, which is going to be length, width, height, or depth. So taking a look back at my picture, I'm going to call my y my length. I'm going to call this x across the top my width, and this x that looks like it's going up is my height. So let's go ahead and plug that in. So I'm going to get v of x is equal to my length, which was y, my height, my width and my height, both x. All right, so I get x squared y. Now, that's not what they're asking me to prove this is equal to. If you take a look at the comparison of the two, it looks like I'm supposed to replace the y with something. This is where the original piece of information comes from with the whole length and the girth, and it can't be more than 120. So I know that if I take the length and the girth all together, I'd better get 120 inches total. So the length is y. So my length, let's go ahead and set it up with this, plus my girth can't be more than 120. Okay, well my length is y. The girth, they told me, is the perimeter of a cross section. So if you take a look at the purple dots on here, that's going to be my girth. And each one of those is x, and I have 4 of them. So it's going to be y plus 4x being my girth, is equal to 120. Now that I have that, I can get y equals, so I can plug it into the other equation and get the y to disappear. So let's plug that in right there. So my volume is going to be x squared times what my y equaled, so which was negative 4x plus 120. It still doesn't look the way that they wanted it to, so I think I'm going to have a common factor here. So I think 4 can come out of that. Let's reshuffle this a little bit. There's a 30 and there's a minus x, and let's see how that compares. Yep, matches exactly. All right, so I just showed that the volume was what they told me it was going to be. Let's take a look at part B. Okay, so part B of the same question, we're going to use our graphing utility, calculator. Graph the function, approximate the dimensions of the package that yield a maximum volume. Okay, so we're going to do the exact same thing that we've been doing with our application problems. So I am going to go to my y equals button, and I'm going to clear out whatever's there. And then I'm going to go to my y1 and I'm going to type in my volume function from above. Then, before I even continue on with this, I want to get an idea of what I think the domain is so I can fix the window. And if I take a look at this, the domain, doing the same thing that I did previously, if I set this thing equal to 0, looks like it's going to be between 0 and 30. So this is going to help me figure out what my window is going to be or what my table set is going to be. So I would say that I want my domain to be between 0 and 30. Just give me an idea of how to set up my graph and how to set up my calculator, so it gives me an idea of where I should be looking as opposed to everywhere else. So I went to my table and I scrolled through my table for 0 through 30, and I noticed the values go up pretty high, and it looks like the volume and my y value on this, my volume, gets pretty close to like 17,000, so pretty high. So I think what I'm going to do is I'm going to set my window so I can see my graph, because I want to actually find out where the maximum is. I don't want to just approximate it this time. I'm going to set my window so that my x minimum is 0, my x max is 30, my y minimum is going to be 0, and my y maximum, I think I'm going to make it pretty high, so let's go up to like 17,000. Just based off of what my table is showing me, it looks like it's getting up there pretty high. After I've done that, I'm going to go ahead and hit my graph button. After I've hit my graph button, I should have a pretty good idea of what this thing looks like from 0 to 30. Now, I go through and I calc. So I'm going to calc and calc the maximum, and then follow the exact same keystrokes that we did on a previous set of notes. So you're going to do the left bound, you're going to do the right bound, we're going to calculate the maximum itself, and I would pause it now if I were you, because I'm going to go ahead and write down what it is, because I've already done it on my calculator. I got the maximum at 20.0000, comma, 16,000. All right, so what this is saying, this is the x value, and remember we let the y value represent the volume, so the maximum volume is going to be 16,000. But the question says that we want to find the dimensions of the package. So I already know the x, so now I just need to plug it in to find the y. So my y is going to be 120 minus 4x, which is equal to y. Plug in my y, which is going to be 20, and I get 40. So the two dimensions that are going to be my answer is the 40 for the y and the 20 for the x. So those are the dimensions that produce the maximum volume. I'm going to go to the next slide so we can do the last part. Okay, so the last part for these notes, and this is going to be part C of example number 7. We need to find the values such that the volume is going to be 13,500. And then we want to talk about, well, why can't one of them actually work? So I figured we would just do this algebraically, give us a little bit more practice. So I'm going to take the volume function, and where the v is, I'm just going to plug in 13,500. Okay, so now there's a couple of ways that we can do this. I am going to go the algebraic route though. So with the algebraic route, I want this to be equal to 0. So I'm going to go ahead and distribute, rearrange this a little bit so my cubed comes first, and then move my 13,500 to the other side as well. All right, I'm not a big fan of trying to do the P's and Q's on this one. So I think what I'm going to do is I'm going to use my calculator. So in my calculator, I'm going to go to my y equals, and I'm going to go to my y1, and I'm going to type in the equation that I just got, just getting rid of the 0 itself. Now, what I'm looking for is I'm looking for the zeros. So I'm going to go to my table from here, and I'm going to look for y equals 0. And it really doesn't take me that long. I find that 15 actually works. So I'm going to set up my table because I need the resulting polynomial out of this. And this is a cubic, so my expectation is there's going to be 3 of these answers. So I have a negative 4x cubed, a 120x squared, no x, don't forget to fill that in, and a negative 13,500. And I got the 15 to work from the table. So now I'm just going to go ahead and fill those values in. So if I do my multiplication and then my addition, just doing what I would normally do for my synthetic division table. Okay, so now because this is actually was a cubic, it's now squared. This I can handle. I don't need any more synthetic division. I just needed one value to come out of this so I could break it down into something that I'm comfortable with. And then from here, I would go ahead and either solve by completing the square, or I would do the quadratic formula. But I see this thing is divisible by -4, so I'm going to get rid of that. I'm just going to make my numbers a little bit smaller for myself. It'll probably make my life easier when it comes to the factoring part. Okay, now I think I'm just going to do quadratic formula. Alright, so just plugged it into my quadratic formula, grab my calculator, and I'm going to do the math on this. So the inside ends up being root 1125, and the bottom is just 2. Well, the inside can be simplified. That's going to be 15 root 5 all over 2. Okay, so that means that these are also going to be zeros. But we need to talk about the physical impossibility of this. This is actually 2 different answers. We have the plus part and we have the minus part. So the plus part's not an issue. Remember that the x represents a dimension. So if I were to add those together, I'm going to get a positive number. So this is good. But the other one, not so much. If I were to subtract these two, I am going to get a negative number. Since this is a negative number, this is not going to work. Negative numbers, you can't have a dimension that's negative. Which means this is the physical impossibility, which means this one is no good. We cannot keep that one. So although it shows up algebraically in context with the question, it doesn't make any sense.